Hi students, let's look at this question here, which is on the application of differentiation. This is actually on connected rate of changes. Let's say I can do this proficiently. So water is flowing in an inverted upright cone of height h. So just take note that h is a constant. So I'm going to just draw it out because that very likely you need it. So this case here, this height here corresponds to h, and then after which this length here will corresponds to r. So this is big R, then this is h. This is 90 degrees. Okay, then after which water is going in. The radius of the surface of the water is increasing at this rate. So the radius of this circle here, this is r. This is a variable because as water goes in, you can imagine as water goes up, this r is changing with respect to time. So you just let radius of water dr. So hence, given that dr dt, so this case here, you know that dr dt is actually km. Okay, so find h or r, in terms of h or r and l. I mean, this is l or r. The rate of, we need l, or there's no l, or r. The rate of change of the curve surface area of the cone that is in contact with the water and the cone is filled. Okay, the cone is filled, meaning the volume of the cone, right? The volume of water here, volume of water, this tells you that the volume of the water is 1/8 of volume of the cone. Okay, so this one later on we need to talk about it. Now the first thing is to understand you want the curve surface area, the rate of change of curve surface area, meaning to say you want A. Now A, let A be the curve surface area. Let N curve surface area A. Okay, so what you need to find dAdt, right? So the first thing you should do is use chain rule, straight up chain rule. Always do this. We put dA something equals to something dt. Now this is not typo, so you just do this first. Then what you would notice is you need to put something here, and you look at this, you are given dr dt, so of course this will be dr dt, because once you fix this already, you have this. So in order for this to be equivalent, to be equal to each other, so this has to be dr. This will then prompt you to find a in terms of r. Okay, so it shouldn't be a problem. Curved surface area is pi rl. We know that. So pi rl means that this is L here. So this is L. But the problem here is that you know that R and L, they are varying. So this is a two variable equation, So you need to use some form of constant, some condition to change A into one single variable, namely in terms of A, because R. Okay, because you need that. So what we're gonna do next is essentially just I'm gonna just look at this. Oh, this is pretty okay, because you look at this slant height here, you can use similar triangle. So by using Pythagoras theorem, we know that this case here, this over here will be r squared plus h squared square root. Okay, so in other words, using similar triangle, this over this will be this over this. Okay, so by properties of similar triangle, properties of similarity, we know that big R over small r will corresponds to the slant height r square plus h square over L. Now the reason being is because if I can make L so in terms of the other constants here, I mean the one variable, then it will be great. So I'll just sub 1 to 2 So sub 1, 2. Then what we get is a pi r over r square plus h square. Now there you go. Once done, shouldn't be a problem there. So I will gather that these are all constants. So the constants, I'm not too worried. Okay, so just bear in mind that these are all constants. This whole gibberish here, these are all constants here. So just leave it as constants. Okay. So now I can go back to my dAdt. This is like my side quest. My dAdt, I need dAdr. So dAdr, just differentiate r square. Because these are constants, just leave it. So it's 2r pi r square plus h square. Great. So in other words, now if I were to substitute it in, so dAdt will just be, maybe I should just dAdt. You just swap the space. It'll be like that. This is like that. Okay, so I'll move on with this one. Now dAdt, dAdr will just be 2r. So I'm going to sub this in 2r. Substitute this in will be 2r pi over r square plus h square. Then dRdt, this will be k. Is it k? It's k, right? It's k, yeah. So there you go. So hence, dAdt will be given by this equation here, which is 2r pi square root r. Just do this. 2 pi kr. Okay, great. So this is done. Then the next thing we need to do is at this juncture, meaning at this specific value, at this boundary condition here, what is the rate of change in terms of r and h? Because now we have, r and capital R, capital H. There's a small r there, so we're just going to find it. So this is what you write at 1/8 of its capacity. We know that the volume of water is an 1/8 of vol of cone. Okay, so that's the main thing. So in other words, vol of water is just a third pi r square small h. So there's a small h here. We'll just let this be small h. Then the 1/8 of the big 1/8 of 1/3 pi capital R square h. Okay, so if you were to cancel this out, cancel. So I'm just gonna R square h is equals to R square h over 8. All right. Now the thing is, we have an extra h here, so we need to go and find out what's our h here again. So if you use similar triangle, small r over h will just be, or rather, property of similar triangle, big R over small r, okay, will just be small h over, okay. So just look at the triangle there. So this big triangle, the small triangle, and maybe I should draw it out just now. So this is capital R, this is h, this is square root r square, h square, and then this is r, this is h, this is l. Okay, so yep, this triangle is important. If you don't have this triangle, probably quite tough. Just draw this out. So this is 90, this is 90. So I'm gonna just small r, h. Okay, great. So we know that r over also h over h. So this will be h equal r, h over r. Substitute it in will be r square. R h over r equals to r square h over 8. Okay, I do all these just so that I could find my what's my small r in terms of the huge h there. So this will be r cubed over 8r cubed. Okay, so maybe then skip says r cubed. So this will just cube over. So r will be cubic root of r cubed over 8, which is r over. Okay. So at this juncture, you know that small r is equal to r capital R over 2. So in that case there, so when r equals to r over 2, we want to find out what is dA dt. So I'm just going to copy that dA dt at the boundary condition where r equals to r over 2. That will be given by 2 pi kr. So 2 pi k r over 2 square root of r square plus h square over r, and that will give us cancel. Just do some basic manipulation there. Pi k r square plus. Okay, that's how we do this question here professionally. If you have any questions at all, please let us know, and I'll see you in the next.